So there are two special latitudes on the Earth that for at least one day of the year, they get 24 hours of sunlight or 24 hours of darkness. And those two latitudes are the Arctic Circle and the Antarctic Circle. They're at latitudes of 66.6 degrees north and minus 66.6 degrees south. They're way up there, right? So they are special because since the Earth is tilted on its axis, right? If the sun, say, is over here and it's shining its light from the left side, so we'll say that's the sunlight, it's coming in, it's illuminating all of the left half of this Earth, right, as Earth spins. The circles are defined by this point on top, right there. You see that? This Arctic Circle line for this day of the year, which happens to be the June solstice because the sunlight is coming directly on top of the Tropic of Cancer. For observers within the Arctic Circle, they're going to get 24 hours of sunlight. Because if an observer is standing, let's put this in red, if they're standing right there, just inside, that's their daytime. So they're going to look up in the day to see the sun. But at their quote-unquote nighttime, they're going to be over here. So at nighttime, they're going to look, well, try it at least, and look away from the sun. They'll look over there. But they'll still see the sun because the sun's rays will still be shining. Well, I guess that's in black. I can't see that. It'll still be shining to their position, right? It's not blocked. So they get at least 24 hours of sunlight. The closer to the poles they are, the more days of perpetual sunlight you get, right? And so if you are an observer on the North Pole, standing on the North Pole, effectively just spinning around, right? You'll get 6 months of sunlight. That's a long time, right? 6 months of day. And those 6 months occur in between the equinoxes from March 21st to September 21st, right? That also means they get 6 months of nighttime too, which is also equally, if not more strange, right? So this defines the circle. It's the latitude that passes over the actual physical top spot of the Earth, right there on top. That's it. But it's the latitude line, so it runs perpendicular to Earth's axis. It goes that way, which is perpendicular to the axis, which is like that. Okay? And conversely, for the Antarctic Circle, this is June 21st. I should probably write this. Where do I want to put this? This is, let's put this in black. This is June 21st. So in the southern hemisphere, observers in the Antarctic Circle, right, way down, oh, let's turn this around and put a human way down there, right? It's not that they're upside down, right? They're just on the other side of the Earth. They are in 24 hours of darkness, at least, because the sun's light is being physically blocked by the Earth itself. And as the Earth rotates, they are going to come around to this spot now, and they're going to stand. I know it's really small, but if you look very, very closely, the sun's light, oh, that's in black again. The sun's light will come in and will be blocked by Earth itself and cannot reach the physical location where they're standing, right there. They might see a twilight, right? They might see the sun as if it were just about to rise above the horizon, but it would not actually rise above, right? So they might see some kind of twilight or pre-sunrise, not a full day. And so for observers on the South Pole, whoops, let's try and draw upside down here. If they're standing right there, not to scale of course, then they get 6 months of night, right? They also get 6 months of day, but on June 21st, they have all night, all dark. It's incredibly dark, okay? And so their darkness starts on March 21st and ends on September 21st. It's the inverse for the northern hemisphere, okay? So these are the tropics, right? This is what it may look like. In the top, or the top image, is a series of images, a series of 24 images taken 1 hour apart of the sun from a spot inside the Arctic Circle. And you know it has to be inside the circle because, well, the sun never dips below the horizon in 24 hours. So their midnight is right there, or one of those. Midnight, the sun is still above the horizon. That's completely foreign to me. That's very, very weird to think about. Their noon, the sun is still highest in the sky, but it's not that high, right? It's pretty close, but that's their noon, right? So this is not necessarily the June solstice, but sometime in the summertime for an observer inside the circle. Okay? The bottom image is for an observer in Fairbanks, Alaska, which is just outside or just south of the Arctic Circle. And this is actually on the winter solstice, right? I got this from where I got the picture on my regular PowerPoint slide. We see 1, 2, 3, 4, 5, 6, 7 hours of day. That's it. 7 hours of daylight. But of course, their day, the sun remains pretty close to the horizon. So it's not really a day like we know here in Fresno, right? Their noon, well, their noon is when the sun is right there, right? It's highest in the sky at noon. Again, very, very weird. And so most of the quote-unquote day, most of their 24 hours, the sun is spent below the horizon. It's dark, right? It's the longest night of the year for observers in the northern hemisphere. And so in Alaska, it looks very different from the sky in Fresno, right? But again, the top image is from a point inside the Arctic Circle. The bottom image is from a point just outside the Arctic Circle. All right, those are the circles.